and welcome to the Chemistry Academy. In this video we're going to go through skeletal structures of organic molecules that is applicable to the Advanced Higher Chemistry course in Scotland. So skeletal structure doesn't really need much of an introduction. It's essentially just the most simplified way of drawing an organic molecule, and we do so by, instead of drawing the carbon and hydrogen atoms in, we just draw them as solid lines. Any other atoms other than the carbon and the hydrogen in the hydrocarbon sections are written with their element symbol, and any hydrogens that are joined to an atom other than a carbon will also be shown. But the hydrogens joined to any carbon atoms are not shown in the skeletal structure. So it's a very straightforward linear way of representing molecules. Got a few examples here of some skeletal structures, and start off with what we're going to do is show you how that would translate to the full structural formula that you're used to looking at like National 5 and higher. So for this first one, now every line has a carbon at each end of it, and the carbon is has its valency satisfied by hydrogen atoms. So there's a carbon here and a carbon here, so that would be like having two carbons either side of that line. And because these carbons have only made one bond each, they're going to have to make three more bonds, so it will be CH3 at each side. So this straight line here is essentially ethane, which is a CH3 bonded to CH3. We do the same thing here for this one. So here's our first straight line here. There's a carbon at this end, a carbon at this end, and then we've got another line, but that goes to the oxygen, so there's actually an OH group there. There's not a carbon on this one. Okay, so if there's another atom shown, it's not a carbon at the end of the line, it is that other atom. So then if we see how many hydrogens we need, this carbon at the end has made one bond, so that's going to be a CH3. This carbon in the middle has made two bonds, so that would be a CH2. And then that is our OH hydroxyl group there at the end. Okay, so that is the representation of that. Normally you would be used to drawing it out like CH3, CH2, OH in a straight line. In skeletal structure it tends to be drawn in angles just so we can see where the different lines are, and then we can count all of our carbons. So then this last one here, our first line will have a carbon either end. Then we've got a double bond, which will have a carbon at this end, and then we have another line which would have a carbon at that end. So you can see that each sort of point on the lines is representative of one carbon. If we then look at how many hydrogens there are, this would be a CH3 because it's only made one bond. This carbon's made three bonds already, so that's just going to have one hydrogen on it. Same for this carbon here, that's made three bonds already, so again just one hydrogen on it. And then this carbon at the end will be a CH3 again. Okay, so that's how you can convert the skeletal structure into a full structural formula. That's not really something you're really asked to do very often. The most of the time you're either asked to draw a skeletal structure of a molecule from its name, or write the molecular formula for a molecule having been given the skeletal structure. So we're going to do some examples of both of those skills, and then hopefully you'll be able to go and try some in an SQA pass paper and get them all right. So pentan-2-ol, we know that's 5 carbons with a hydroxyl group on carbon 2. So we start off by drawing our carbon chain. So for 5 carbons, just remember there's one at each end, so that's 1, 2 carbons I've drawn in so far. 3, 4, 5. Okay, and you can do a double check at the end. So each point's a carbon, so 1, 2, 3, 4, 5. Then we want a hydroxyl group on carbon 2, so we can either make this carbon 2 or we can make this one carbon 2, it doesn't really matter, but we just draw a line and write OH. Just make sure that you show the correct connectivity. So by that I mean don't write OH where it looks like the hydrogen's bonded to this carbon here. Make sure it's the oxygen that's directly at the top of that bond. So that would be our pentan-2-ol skeletal structure. Hexanal, so that's an aldehyde with 6 carbons. So if we draw our chain of 6 carbons first of all, so we start off, when your pen hits the paper, count that as 1, 2, 3, 4, 5, 6. So you just keep drawing zigzag lines with points But like I said, don't forget to count the first dot on your paper as one carbon. Then if it's an aldehyde, the carbonyl group is at the end of the carbon chain. So that means that at the very end of our carbon chain, we do our carbonyls, we put a double bond to an oxygen. So again, we can double check at the end. We've got 1, 2, 3, 4, 5, 6 with a double bonded oxygen. Then if we go to butanoic acid, so that's a carboxylic acid with 4 carbons. So 1, 2, 3, 4, that's our carbon chain. And then we need to put our carboxyl group at the end. So we do our double bond oxygen and then the OH. One thing I should have actually put as an example here, so let's add in a number 4. We will do propanol. Okay, so this is one that sometimes catches people out. So propanol has got 3 carbons and it's an alcohol. So we would draw our chain of 3 carbons, so 1, 2, 3, and then we put the hydroxyl group on. What a lot of people do is put the hydroxyl group on without drawing an extra line. So if you do that, you've only actually drawn ethanol because there's 1, 2 carbons and then that's an oxygen. So 1, 2, 3 and then an extra bond to the OH would be propanol. So just watch out for that when you're drawing some of the smaller alcohols or any of the 1-ols if they're longer. Make sure you draw an extra bond going to the hydroxyl group and don't just put it on the end. You don't need to do that for the other functional groups like the carbonyl and the carboxyl because the carbon is contained within those functional groups. It's just the hydroxyl and also an amine as well would have to be an extra line and then the NH3. Okay, so just watch out for that. If we then go on to writing the molecular formula from the skeletal structure, so one thing I always encourage people to do in these questions is to draw the hydrogens on. So we know that this carbon here is a CH3, so I'm putting 3 hydrogens on it. This carbon's made 2 bonds, so it needs 2 hydrogens. This one's made 3 bonds, so it needs 1. This is another 3 hydrogens here. There's 2 hydrogens on this one. This carbon here has made 1, 2, 3, 4 bonds, so there's no hydrogens on it, and then that's not a carbon, that's an oxygen. Okay, so once you've drawn in the hydrogens, the other good thing to do is if you can take a highlighter or a different colour pen or something into your exam and dot where the points in the line are, so dot for where there is a carbon. Okay, so again, every point on a line in the zigzag is a carbon except for if there's another atom shown. So then once you've done that, it makes it really easy to put your molecular formula together. So we count how many dots we've got. So we've got 1, 2, 3, 4, 5, 6 carbons. So that would be C6. We then count our hydrogens, and while you count the hydrogens, score them off just so you don't miss any. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the last atom you need to include is the oxygens, and there's 2 of them. So that'd be O2. Okay. So if we do the same process for this one, this here is a benzene ring, which is C6H6, but so basically it's a hexagon of carbons with alternating double bonds. So you will see this quite often in organic chemistry, but what you need to remember is because they're double bonds, basically all of these groups are CHs, so they're all like a CH, 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 except for if it's up here. That essentially is made 4 bonds. If the circle confuses you, the good thing you can do is actually draw in the double bonds. So if you just draw in that on top of your picture, then that reminds you how many bonds that carbons have made. Okay, so if we draw on the hydrogens, we'll start with this one. We'll start with the benzene ring actually. So this carbon here has made 1, 2, 3, 4 bonds, so it's not going to have any hydrogens on it. This one here has made 1, 2, 3 bonds, so that's going to have 1. This one here has made 1, 2, 3, so that's going to have 1. This one has made 1, 2, 3, so that's going to have 1 hydrogen. This one here has made 1, 2, 3, so that's again going to have 1 hydrogen. This carbon here, though, has made 1, 2, 3, 4 bonds, so that's not going to have any. This carbon here has made 1, 2, 3, 4 bonds, so that's not going to have any. And this carbon here has only made 1, so it's going to have the 3 hydrogens on it. Okay, it might actually be easier for you now thinking about it to dot the carbons first before you start putting the hydrogens on, just so you remember where the carbon atoms actually are. And then there's also a carbon here, but that's made 4 bonds, so that's not got any hydrogens on it either. So now we've drawn on the hydrogens, dotted the carbons, we can go and count everything. So for the carbons, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that'd be C9. And then for the hydrogens, again, scoring them off as we go. 1, 2, 3, 4, 5, 6, 7, 8. And then the oxygens, lastly, we've got 1, 2, 3, 4 of them. So C9H8O4. It's the cyclic ones that you want to make sure you're scoring off the hydrogens, because it's when you go round in a circle you get a bit lost. So then the last question, I'll do it this time dotting the carbons. So we've got a carbon here, a carbon here, a carbon here, a carbon here. Remember, there's not a carbon there because that's showing there's an oxygen. We've got a carbon here and here, and then that's an NH3 group, so that's not got a carbon at that end. So remember, if there's a line that doesn't have another atom at the end of it, that's where a carbon is. So if we put on our hydrogens now, so this carbon here has made 1, 2, 3 bonds, so that's going to have 1 hydrogen. This one here has made 1, 2, 3, 4, so that's not going to have any. This one's made 1, 2, 3, 4, so it's not going to have any. This one's made 1, 2, 3, so it's going to have 1 hydrogen. This carbon here has made 1, 2, 3 bonds, so that's going to have 1. This carbon here has made 1, 2 bonds, so that's going to have 2 hydrogens, and then that's us. So now the easy bit, counting them up. So we've got 1, 2, 3, 4, 5, 6 carbons. And then the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you can just double check you've not missed any. And then lastly, the oxygen, or oxygens and nitrogens, we've got 3 oxygens, so O3, and then nitrogen. Doesn't really matter which order you put the oxygens and the nitrogens in. Oh, I've missed an oxygen, there's 4 oxygens. So it doesn't matter which order you put the oxygens and the nitrogens in, you can put them in any order you like. I'll just rewrite that because it was a bit messy. So C6, H10, O4, N. Okay, so that's my top tips from skeletal structure. Hope you found that helpful. If you did, please give it a like. Don't forget to subscribe and tell all your chemistry friends about my channel, and I'll see you again soon.